Saudi Arabia, a country with almost no rivers, huge stretches of empty desert, and under the desert, some of the largest oil reserves on earth. Kuwait, smaller than Kerala. Iraq, a country battered by wars for decades. Together, these countries hold enough oil to shape the global economy. Now look at India, 1.4 billion people, long coastlines, a manufacturing giant, a country that builds satellites, pharmaceuticals, software, steel. But oil? India imports almost 90% of what it consumes. Every day, millions of barrels arrive from somewhere else. Why? Why does a country this large, this old, this geologically diverse still depend on the rest of the world? The obvious answer seems like India simply doesn't have oil. But that's not entirely true. India has many sedimentary basins, the geological environments where oil forms and accumulates. And here's the part that changes this entire story. Only a few of these basins are currently producing. That too, only less than 15% of Indian needs. Then why did India stop looking for more oil? To answer that, we need to go back millions of years. Oil is not randomly scattered underground. It forms under very specific conditions, almost lab-like. Let's take the Arabian Peninsula as an example. Millions of years ago, much of the peninsula lay beneath a warm, shallow ocean called the Tethys Sea. It was full of life, plankton, algae, marine organisms. When they died, they sank to the seafloor. Over millions of years, layers of sediment buried them deeper and deeper. Heat, pressure, time. Eventually, that buried organic matter transformed into oil. But forming oil is only half the story. To create giant oil reserves, we need three types of rocks. First, source rock, a place where oil forms. It has to be buried deep and for long amount of time to form oil. Second, reservoir rock, a place which collects the oil. Think of it like a sponge that collects all the oil. And third, a trap rock, a sealed structure that prevents the oil from escaping. Let's understand this using a samosa. The filling is the sediments that make oil. The inner flour layer is the reservoir rock that collects the filling. The outermost layer of flour holds both these layers together and forms a trap around them. The Arabian Peninsula has all three. More importantly, they stayed largely stable. The Arabian plate moved slowly for millions of years. No massive collisions with other plates, no giant volcanic eruptions. It got the perfect recipe. We could say the samosa got the perfect time and place to cook without breaking. India's story was far more violent. Around 66 million years ago, when India was an island, one of the largest volcanic eruptions in Earth's history occurred. It flooded western India with lava, thus formed the Deccan Traps. For thousands of years, molten rock spread across huge parts of the subcontinent. Today, some of these lava layers are nearly 2 kilometers thick. You can clearly see here how lava cooled in layers. And beneath them, hidden under the volcanic stone, lies oil. Later, unlike the Arabian plate, the Indian plate moved very fast. It smashed against the Eurasian plate, forming the Himalayas, the world's highest mountains. These collisions are terrible for preserving oil. Sedimentary layers get crushed, broken apart. The neat underground traps that hold oil can rupture and leak. Thus, the oil systems of India became deeper, messier, harder to find. Getting back to our example, the samosa was made in a hurried and violent fashion. It caused the filling to spill out, scatter at times, buried deep beneath many layers of flour. And yet, India is not empty. The edges of the subcontinent tell a different story. Assam has produced oil since 1889, the oldest oil production in whole of Asia. Gujarat's Cambay Basin became a major producer in the 50s. Rajasthan was only discovered in the 90s. And offshore, beneath the Arabian Sea, India found something extraordinary. February 19, 1974, the world was in turmoil. The Arab oil embargo had triggered a global energy crisis. Prices were exploding. More than 150 kilometers off the coast of Mumbai, a drilling platform called Sagar Samrat struck oil, Bombay High. It changed everything. By the late 80s, Bombay High was producing nearly 470,000 barrels of oil every day. For a moment, it looked like India might finally reduce its dependence on foreign oil. But Bombay High peaked in 1989, just 15 years after its discovery. Today, the output is barely a fraction of what it once was, and India never found another Bombay High. This is where geology stops being the whole explanation and policy begins. India has 26 sedimentary basins, but only a handful ever saw serious production. Large parts of the Mahanadi Basin, the Andaman Sea Basin, the Vindhyan Basin remain non-productive even today. Three main reasons caused it. 1. Till the late 90s, exploration was dominated by state monopolies. 2. Huge areas were classified as no-go zones, blocked by defense rules, environmental clearances, etc. 3. This was the biggest challenge of all: deep water. Much of India's promising sedimentary basins lie far offshore in waters thousands of meters deep. Finding oil there requires advanced rigs, specialized ships, and enormous investment. By the time India seriously began opening these sectors, the world had already spent decades mastering offshore drilling elsewhere. India wasn't entering the race early, it was arriving late after much of the easy oil age had already passed. And the cost of that dependence is enormous. India imports roughly 5 million barrels of oil every single day. That's about 40,000 oil tankers parked bumper to bumper from Delhi to Amritsar, or from Bengaluru to Thoothukudi. And India imports this amount of oil daily. A blockade in the Strait of Hormuz, a conflict in the Middle East, sanctions on Russia, and suddenly the price to keep India moving becomes dramatically more expensive. Now comes the uncomfortable question. Does any of this still matter? The world is changing. Electric vehicles are growing. Solar power is becoming cheaper. Countries everywhere are moving beyond fossil fuels. So why invest billions searching for oil now? Because transitions take time, and modern India still runs on petroleum. Domestic oil wouldn't magically solve everything, but it would buy leverage, security, breathing room. And India is trying to move ahead. Restrictions are slowly being lifted, policies are being amended, deep water exploration is expanding, private and foreign investment is being encouraged again, but the timing is difficult. And that is the strange irony at the center of this story. India may still be sitting on significant oil reserves. The geology surely points to it, which means the story was never only about geology. Yes, India's violent geological history made oil harder to preserve and much harder to find. But another part of the story was human. The years lost, the delays, the hesitation, the decades spent not fully exploring. We can't rewrite our geology, but we can change our choices. Because geology alone never decides destiny. Countries and their choices do.